So we're going to start talking about quadratics by looking at examples and non-examples. So with your eyes, tell me something that a quadratic is or something that a quadratic is not. Andrea. A quadratic is a parabola. We see parabolas. The parabola is the graph of a quadratic. That is something it is. Can you tell me something that it is not in that same vein? If a quadratic is a parabola, what is a quadratic not? It's not linear. So these non-examples show a line. So a quadratic is nonlinear. Okay, when we're talking about nonlinear, and specifically, our parabolas are a curve. So when you're like, it's on the line, there is no line for a quadratic. It's a parabola, it is a curve. Based on something else you can see with your eyes, what is something a quadratic is or something a quadratic is not? It can have two x-intercepts. That's awesome, Adrian. It can have two x-intercepts. In this case, it had two. How many x-intercepts does it have in this case? One. So it could just have one. What else could we say a quadratic is or is not based on these examples? What do you think, Brooklyn? It has a vertex. Yeah, it has a vertex. What else, Adrian?
The line of symmetry or no?
It has a, so it's a symmetrical graph. The graph is symmetrical, and it's symmetrical around the axis of symmetry. Yeah. What about the equations? What is something that a quadratic would have in the equation that, a non-quadratic doesn't? John? It's got a degree of 2. We're going to have an x squared term. We do not have that over here. Not the same. Anything else? So remember last semester we talked about constant rate of change. You didn't have to be going by the same step every time on x, like this is plus 2, plus 4, plus 4, plus 2. But something was linear if it had a constant rate of change. So that meant negative 1,440 divided by 2 is the same thing as negative 2,880 divided by 4. So in this case, our change in y over change in x is a constant rate of change. It's decreasing 720 y per x. But on our quadratics graph, it's not doing that. It's all increasing by 1 each time on my x, but on my y, to get from negative 3 to negative 4, I have to go down 1, but then I bounce back up. From negative 4 to negative 3, I add 1. From negative 3 to 0, I add 3. From 0 to 5, I add 5. So the important part of a quadratic and what you have to look at for a table is what we call a common second difference. This is the first difference. But if I look at the second difference, each time the second difference is increasing by 2. This has a common second difference, and therefore this table is a quadratic. A quadratic function is a nonlinear function whose graph is a parabola with a common second difference. You know the standard form of a quadratic. We've talked about it before. Y equals ax squared plus bx plus c. Something you may not have gotten to in your textbook reading last night is vertex form. Vertex form is y equals a times x minus h squared plus k. Okay, what we're going to do first is we're going to start by looking at our quadratic parent function. This is just the most basic parabola. We're going to talk about all those vocab terms we talked about that were in your homework last night, and we're going to apply them to the parent function. And if the parent function of quadratic, y equals x squared. But what's the value of a? 1. So let's make a table of values. Let's plug in our x's and get some y's. If I plug in negative 2, what do I get for y? 4, because negative 2 squared is 4. What's negative 1 squared? What's 3 squared? So we're going to take this, we're going to graph these points. What else could I graph on this? Yeah, negative 3, 9, because it is symmetrical. When you connect the dots for a parabola, remember that a parabola is not a line, it's a curve. So there should be no straight lines. You shouldn't be like connecting dots into straight lines. You're going to curve, and down here it's not a V. It's like somewhere between a V and a U. You curve through it. So when you're graphing, I will not want to see a pointy V for your parabola. Because a parabola is a curve. We know that the axis of symmetry is the vertical line that splits the parabola in half. What is my equation for my axis of symmetry? X equals 0. We know that our axis of symmetry goes through our vertex. Our vertex is our point at the maximum or minimum of our parabola. So what point is my vertex in our parent function? 0, 0. My maximum or minimum happens at that vertex. Is this a maximum or a minimum? It's a minimum because it's opening upward. Because the minimum value is the y value of the vertex. So my minimum value here is y equals 0. Unless you are given a scenario or situation, the domain of our parabola is what? All real numbers, because it's going forever left and is going forever right. So my domain is all real numbers. But does it go up and down forever? No, it either will go up forever or down forever. So my range will have stipulations. My range here is what? Y is greater than or equal to 0. My y-intercept is where we cross the y-axis. What's my y-intercept here? 0, 0. And my x-intercept is where we cross the x-axis. 0, 0. So if I plug in a negative 1 to my function, remember with a negative value you need to use parentheses. Negative 1 squared minus 4 times negative 1 plus 3. 1 plus 4 plus 3. 8. 0 squared minus 4 times 0 plus 3. 3. 1 squared minus 4 times 1 plus 3. 0. 1 minus 4 is negative 3 plus 3 we get 0. 2 squared minus 4 times 2 plus 3. Negative 1. 4 minus 8. It's negative 4 plus 3. Negative 1. Do you see a pattern now in my table?
Yeah.
So 5 squared minus 4 times 5 plus 3. So now let's graph. Okay, something I forgot to point out is on the parent function, when we graph, something that can make our lives easy because a is equal to 1 is we go over 1 up 1 because 1 squared is 1. Go over 2 up 4 because 2 squared is 4. Go over 3 up 9 because 3 squared is 9. And that has to do with that x squared right there in that a. So if we look at this different function, it's not the parent function, but because this term is x squared, this actually from the vertex relates very much to the parent function. If I went over 1, what's 1 squared? Up 1. Over 2, what's 2 squared? Up 4. Over 3, what's 3 squared? 9. So one thing that we're going to learn tomorrow is that if you can find the vertex and you know how the graph relates to the parent function, you don't have to make a table of values to be able to graph very easily 3 points and then reflect them over your axis of symmetry. What is my axis of symmetry here? So remember that your axis of symmetry is an equation for your vertical line. So tell me the whole thing. X equals 2. And remember that your vertex happens on your axis of symmetry. So those x values need to be the same. But my vertex is an ordered pair. What's the value of my vertex? What's my ordered pair? X first, Thomas. 2, negative 1. My x-intercepts. What's my y-intercept? 0, 3. Does this have a maximum or a minimum? It has a minimum. And what is the value of my minimum? The minimum is the y value. So remember that we're talking about the y value here. What is my domain? All real numbers. And what is my range? Y is greater than or equal to -1. Okay, we're going to do another one where we're going to make a table, but we're going to use a calculator because I'm not going to torture you all day. So -0.5 times, remember you've got to use parentheses if your x value is negative, -2 times -5 plus 6. So I plugged in -5 and I get 3.5. So I'm going to plug in -4. Do it again. Plug in -2. Plug in -1. I'm not going to use the calculator for 0 because I can plug in 0 quite easily. 0 minus 0 plus 6. Change that to a +1. Plug in 2. All right, so graph this parabola. Now, to make my parabola the most beautiful, I noticed that the right side has some points that the left side doesn't have. Can I just add those points? Because I can tell, because I have a point on this side here, and a point with the same y value here, I can see where my axis of symmetry would be, because it has to be in the middle of these 2 points, or in the middle of these 2 points. So I know that my axis of symmetry is right here. So what's another point I could add to my parabola? All right, -3, 7.5. -6, 0, because I have my 0 right here. 1, 2, 3, 4 from the axis of symmetry. Over here, 1, 2, 3, 4 from the axis of symmetry. And then connect your points. How does this graph change? Is it different from the 2 graphs we've seen before? It has a maximum. It opens downward. Remember how with your parent function from your vertex, if you went over 1, up 1, over 2, up 2, because 1 squared is 1 and 2 squared is 4. Sorry, up over 2, up 4. Remember that? We talked about that like a second ago. Over here, because A is not 1, the negative makes this turn downward. And the 1/2, you can see it with, instead of over 1, down 1, we went over 1, down 1/2, because 1/2 is half of 1. Over 2, whereas on our parent function we would go over 2, up 4. Over here we go over 2, down 2, because half of 4 is 2. Whereas in our parent function we went over 3, up 9. In this one we go over 3 and down how much? 4.5, because half of 9 is 4.5. So going over 4, in a parent function we would go over 4, up 16, because 4 squared is 16. Here we go over 4, down 8, because half of 16 is 8. Okay, what's my axis of symmetry? X equals -2. What's my vertex? -2, 8. Where are my x-intercepts? -6, 0, and -2, 0. I mean +2, 0. What's my y-intercept? 0, 6. Does this graph have a maximum or a minimum? Has a maximum. What is that maximum's value? Y is 8. What is my domain? All real numbers. What is my range? Y is less than or equal to 8. Okay, let's look at these and tell what's quadratic functions. Is this a quadratic function right here? There's 2x squared, so if I said minus x squared from this side to get them together, what happens to it? It cancels out. Is this a quadratic function? No, what's missing? There's no x squared, there's no squared term. What about this one? Yes, it is. It's quadratic. What about this one? So, if I say minus 2x squared from both sides, does it cancel out? No, I have 2x squared left, so this is quadratic. What about this one? Because if I distribute the 3x, I get an x squared term. What about the last one? No, because there is no x squared. It's got x as the exponent. Is this a parabola? No. Is this a parabola? Yes. It's got an axis of symmetry. It's got a vertex. Is this a quadratic? How do we tell with tables? What do we have to find? The common second difference. And this difference is 2, this difference is 6, this difference is 18? Yeah. The second difference here is 4, second difference here is 12. So not a parabola, not a quadratic. Over here, however, the difference between 63 and 112 is 49. Between 112 and 175 is 63. The difference between 175 and 252 is 77. Do these have a common second difference? What is it? 14. What about the last one? Yeah, it's saying, hey, let's take the x and square it and then make it negative. So negative x squared would be the function here, and that is a quadratic. All right. I told you about the vocabulary. I'm going to make you do a lot of vocabulary today, and then it'll be set like old hat, and you'll be really good at it. This is linked on the page. This is linked on the page. I'm going to give this to you. Your IXLs that I give you today, tomorrow, and Monday are all due next Thursday. I think they're really easy. If they're not really easy, come back and tell me I'm wrong. Okay?